Okay, gang, MATH1700. This is week number 2. We're gonna get real serious this week. Okay, so I don't know how serious we're gonna get. I don't get actually too serious, but what I want to do for you in this video is just kind of follow up on some things that we talked about in the previous video. So what I have is I have some questions I'm going to run through. I think instead of me getting all theoretical and y equal mx plus b's and things like that, I think what helps as much as anything from teaching this class, as much as I've taught it, is let's just get roll up our sleeves and just jump in feet first and and try to learn how to work problems. I think the students find it most productive for me just to work examples. So that's what I'm going to do here. Obviously throughout working the examples, I'm going to try to teach you and try to tell you some things I'm thinking about. So first of all, that should be a plant. So I don't know what a plant is. So a plant can manufacture 100 golf clubs. Didn't you know that those would come up eventually? Per day at a total of $20,000 and 110 golf clubs per day for a total of $21,850. Find the daily cost C of producing X golf clubs. So it looks like what we're going to have here is we're going to create a function C of X, where X is the number of golf clubs and C is the cost for that amount of golf clubs. Guess I'm thinking about that correctly. Yes, I am. All right. So what we know is that C of 100 is equal to 20,000, and we know that C of 110 is equal to 21,850. Now we saw from previous videos that we could take this and create ordered pairs. So we know that when X is 100, that our Y is 20,000. And we know that when X is 110, our Y is 21,850. Okay? Now, gang, what I would do from here is I would use the calculator to come up with this answer. Now, again, if that's something that just doesn't do it for you, and you would prefer to crunch this out by hand, that's cool. But I would use the calculator. So, guys, that's what I'm going to do, and I think I'll just use this. I downloaded my calculator as a software program on the computer, and I'll show you that in just a second. Okay, so if I go to Stat and I go to Edit, so what I want to do here is I want to bring in 100 and 110, and then I want to put the associated cost with 100 and 110, so that's going to be 20,000, and of course 21,850. Okay, now as we saw before, the first thing you need to do, you got a button here that says quit. So we've got to get out of this, so go second function quit, and get back to the home screen to where we can actually execute the command that takes care of this. So guys, if you hit Stat and go over to Calc and come down to number 4, or just hit the number 4, we have linear regression AX plus B. Left parentheses, second L1. Guys, remember, right here we have L1, right there we have L2. That's where we put our information. Well, you can't see that, but let me put this up a little bit. Right here you have L1, and right there you have L2. So bring that back down where the glare of the light isn't as bad. I'll tell you, I usually record my videos, and we have a back room, kind of a back porch thing that overlooks the lake that we live on, and the glare out there isn't as bad. But today it's raining, and I was afraid that if you guys heard the rain, you'd go to sleep on me. So guys, there's linear regression, AX plus B, L1 comma L2. So hit enter and you get your information. Now, so what that tells us is the cost function is 185 x plus 1500. All right. Now, the next thing, you'll see this a lot on my math lab. You'll see that it gives you a domain. And guys, domain is just a fancy smancy way of saying what x values do you want to graph this over. What x values do you want to examine the cost for? Now, for some reason, this problem has decided they'd like to examine the cost from 0 golf clubs up to 200 golf clubs. Okay? So the first thing I've got to do is I've got to, when taking a look at something like this, what I've got to understand is I'm starting at 0 here and I'm going up to 200. So the manner in which I want my x's set in my graphing calculator are clear. Now, it's not as clear where I want to run this to, where I want to run my y to, because if I don't run my y high enough, or if I go too high, it's going to give me a distorted looking graph. So where do I run this? Well, I know I'm going to start at 0, and you know, how far do I go here? Well, usually you can look at the choices that my math lab gives you and see how far this is going to go. So I think the problem that you're going to encounter this week wants you to run that thing all the way up to 20,000. I'm pretty sure. So now watch, I'm going to be wrong. Let me double check that. I tell you, let's back out of this. I wanted to do something, and hopefully nothing on Facebook popped up there. I wanted to show you guys something. I received a couple of emails from you guys about some things. So let me log in. I want to make. Well, I promise you I can. All right, gang. I received 2 emails this weekend that some people got confused on what they're supposed to do. When you log on here, for the most part, you know, there's all kinds of options here. I don't even know if you see some of this, but as a student. But one thing that I know you see is the things up here. Really, for the most part, the only place you're going to want to go when you're interested in doing your homework is just click this homework tab. And when you click, well, it's not a tab, it's a selection. So let's go continue, okay? And there are all kinds of things that you could get into in the study plan if you so choose to do that. Typically, for those of you that are willing to watch all the videos and spend ample time on assignment 1 and 2, because guys, I have no restriction on the number of times you can do these problems. I didn't set it up that way. So if you're able to, just grind it out, be persistent and work the problems as many times as you want until you get them correct. That's going to be plenty. As long as you watch the videos and do the assignments, I don't know that you're really going to need the study plan. But nevertheless, don't get sidetracked. When you log on, just go to homework, and I always close this down right here, and it's going to tell you the homework assignment and the due date right here. This one was due the 31st of December. In assignment 2, more in linear functions has already been posted, and it's due the 7th day of June, again at 11:45. So, you can just click this, and your, the problems will come up. Now, what I want to show you, I think, is on question number 5, one of the things that I wanted to show you here on the graph. Okay, it's not number 5. Let's see if it's number 6. Yes. Now, when you come down to this part right here, graph the total daily cost, you're going to have 4 graphs that are given, and it will give you the pictures of the graph down in here. Well, the reason I'm showing you this, I want to go back over here now, is that all of those graphs will have a value here. And I seriously doubt it's going to be 20,000, but it, it could be. But whatever it is, I'm going to show you how to do this in your calculator. So what we can do if we want to graph this is I can turn the calculator on, and I can come up here to graph. I'm sorry, go to y equals. And, well, we have 185. Guys, right here is your x key. You'll see x, tau, theta, nu. This will be set at x. And then we have plus 1500. Now you're going to go to your window, and you're going to set your x min and x max according to the graph you're trying to match up your calculator with. So we know our x's are going to run from 0 to 200. Guys, I would always set, in this class, x scale for 1. And my y min, I'm going to run those from 0 to 20,000. Or whatever this value right here is on your selections. Whatever that value is right there, that's the value that's going to go in for the y max, because you're trying to match the picture on your graphing calculator with the correct one on my math lab. So guys, now I got ahead of myself, but now I hit graph, and you'll see that you have a graph that looks like this. Now, if you get in a situation where you get an error, sometimes you need to come in, especially if you've taken a stats class before. There's a thing right there called stat plot. Sometimes if the stat plots are set, it can mess with this right here and give you a domain issue. So since we're not going to be doing stats in here, the best thing you can probably do is go second function, stat plot, and let's just go ahead and turn all those off. You see you got the first one on, second one off, third one off, at least I do. Now you probably are different. The quickest way to turn all your plots off is come down to number 4 and just hit enter, and then hit enter again, and it'll tell you that it's done. So when I go back to my stat plot, it's not going to interfere, a scatter plot, maybe the domain for a scatter plot or a box plot or something like that, with the graph that we're trying to execute over here. Now, that maybe didn't happen to you. If it didn't, you're probably thinking, well, why are you talking about that? It didn't happen. I'll guarantee it happened to someone. Guys, I've taught this class too many times. I know those things happen. So, guys, if you did this, when the 4 choices you have on my math lab, you're going to try to find the one that looks like that. And again, this is only a good comparison if our x scale and our y scale are set the same. Okay. Now the next thing is to interpret the slope and the intercept, and we've talked about this before, but let's just go ahead and talk about this. The slope is 185, and the intercept is 1500. Guys, in fancy schmancy terminology, we call this the marginal cost, and we call that the fixed cost. Marginal cost is the cost for one additional unit, and the fixed cost is the cost when 0 units are produced. Okay? So for this golf club manufacturing plant, it costs them $1,500 to open the doors every morning. Every time they create a driver, golf club, it costs them $185. So if they only, for example, let's say they had a really weird day and they only created 1 golf club, then we would have 185 times 1 plus the value it took to open up the door So we have a value $16.85, which is $185 more than it cost to open the door. C of 2, I don't really even need to do this because I know it's going to be $185 more than this. So I know it's going to be $1,870. But if you're calculating something, for example, the price for 72 golf clubs, it would clearly be most effective to use the formula. So guys, if this particular manufacturing plant produced 72 golf clubs, they could expect their operating cost to be, for the day, to be $14,820. Okay? All right, let's get into to problem number 2. And what happens with these problems is there's just additional, spins that are put on these things. So we'll see what's going on here. So Bill sells paintings at local fairs and festivals. His marginal cost to produce one painting is $5.75. His total cost to produce 75 paintings is $781.25. Bill sells his paintings for $9.95. All right, now guys, what I know here, I want a cost function. So I'm going to let X be the number of paintings. And I know I'm looking for two values, two numbers, because C of Q, when we have a linear cost function, C of Q is going to be the marginal cost times the number produced plus the fixed cost. Well, it tells me right up here his marginal cost to produce one painting is $5.75. So without question, without hesitation, I know the $5.75 has to go there. I can also use a little bit of insight to come up with the fixed cost, because I know to produce 75 paintings it cost Bill $781.25. It costs $5.75 per painting. So for 75 paintings, he has $431.25 in the marginal cost component. Well, the difference in that for the $781.25 has to be the fixed cost. So that has to be $350. Because again, the total cost to produce 75 paintings is $781.25. So I'm going to come down here and show that a little bit more. So 75 units created a total cost of $781.25. Now guys, total cost has to be a sum of two parts. What does the total cost have to be a sum of? The marginal cost and the fixed cost. Well, the marginal cost is the price per unit times the total number created. The fixed cost here is the unknown. But I know that 5.75 times 75, which turned out to be $431.25, plus this value has to equal the $781.25. So I can find the fixed cost here just by taking the 431.25 minus the 781.25 to find my fixed cost, which is $3.50. Now, to break even, we know that the break-even point is where the revenue, well, we know that in this case that the revenue function, if Bill sells his paintings for $9.95, guys, I switched variables on you here, okay? You can let it be X or Q. Q is just quantity, X can be quantity too. Just be consistent with it, okay? Which I didn't. Do as I say, not as I do. All right, so we know our revenue function here. If we're selling for $9.95, our total revenue as a function of the number sold, X, has to be $9.95 times X. All right, so let's get out of this and go back over here. So we know, guys, break even happens when our revenue equals our cost. That is almost just good old common sense. When you take in and then you spend out exactly what you took in, and then you're breaking even, okay? So our revenue is going to be $9.95 X. Our cost is $5.75 times X plus 350. So gang, it should be really clear that we're going to subtract $5.75 X from both sides. So we have 4.2X so I'm calling this 84 units. Now, the answer turned out to be 83.33. When I go into my math lab, I will make it where 83 or 84 is counted correctly, okay? But I'm always going to round up when I have a decimal. So, gang, I'm going to go with 84 units. Now, the next thing we get into is we're wanting to make a profit of $1,000. So Bill's going to go to these festivals and fairs, and let's say he doesn't even want to waste his time unless he can make a profit of 1,000. Well, how many is he going to have to produce to make a profit of 1,000? There's actually a place in I don't even know why I thought of this, just because I'm a random thinker. There's a place in Lexington called Spalding Donuts, and these donuts are like almost to die for. They really, really are good. And what they know is they know how many, they know what they want to make. And in other words, they know what their profit is. They know what their profit wants to be each day. So what they'll do is they'll make that many donuts. And once those donuts are gone, they close the door. And oftentimes, if you want donuts really bad at Spalding's, you'll have to get there really early, because sometimes they'll sell out at 9 o'clock, some days 10, some days 11. I've seen them stay open to 1 or 2. But to be sure you're going to get donuts from Spalding's, sometimes you got to get there kind of early. So guys, part C is dealing with profit. So guys, remember that our profit is our revenue minus our cost. So for our problem here, our revenue function is 9.95x minus our entire cost function. Okay, so we're going to distribute the negative through, and if my mental arithmetic is correct, should be 4.2x. Now guys, a lot of people are going to miss this. And when you miss this, you miss the entire problem, which just isn't cool. This cost function consists of the entire 5.75 plus 350. It's really easy not to distribute that negative sign through to each of these terms in the cost function. And if you do it, you're just going to miss the problem. There's no other way to put it. Okay, gang, so we want our profit to be $1,000. And we saw that the profit function is 4.2x minus 350. So obviously I'm going to add 350 to both sides. So left side I get 1350, 4.2x. So again, we're going to have 1350 divided by 1350 divided by 4.2. And we're going to get 322 paintings. So Bill's going to be really busy. 322 paintings. I made this stuff up. I don't know. Well, actually, I didn't make it up. I got it out of a book. But I don't know what kind of paintings he's doing. But let's say he's going to be open, say, 5 or 6 hours. Then he's going to have to be doing a whole bunch of paintings per hour. So work hard, Bill. All right, let's look at number 3. Now, guys, these are going to get just a little bit harder, especially this next problem. This is one of those problems that just drives students crazy every single time I teach 1700. So it says is at a break-even point of 250 units sold, the variable cost were $225 and the fixed cost were $15,000. At what price is the product sold? All right, now this is kind of weird. There's a lot going on this problem. But we know that when we're talking about a break even, then we need two things. We need a revenue function and we need a cost function. All right? So we know from the problem it says that, again, let me bring that there where you guys can see it. We know that from this part right here, we know that the variable costs were $225 and the fixed costs were $15,000. So guys, that tells me that my cost function is known. There's no question about that. Now, something else I know is that the break even is at 250. So we get a break even point. So that tells me that R of 250 has to be equal to C of 250. Well, broke even. At 250, those two values are the same. The revenue, the total amount that was taken in, is the same as the cost that was spent to produce 250, which includes the marginal and the fixed cost, okay? Now, this over here, I can get more information because I know up here that C of 250 can be found by taking 225 times 250 plus 15,000. So I'm just going to put that in my calculator. I'm not going to show you calculator in this situation, but I'm going to type it in, and I get the answer 71,250. My revenue function, as we looked in a previous video, is the price that I sell something at times the number of units that I sold. Well, I know in this situation that R of 250 has to be some price times 250. So I know that this is 250 times the price that the unit was sold at. So I can divide both sides by 250. And the price of the unit was sold at $285. Guys, from here I know without question that my revenue function had to be 285 times X. All right. Now, drum roll please. When we go back to this problem right here, so at what price is the product sold? $285. Now, the next thing, what will the 251st unit contribute to profit? Well, I've got that word profit, which tells me I need to create my profit function. Well, my profit function is really easy to find when I've got my revenue and my cost function, because my profit function is just the revenue function minus the cost function. So my revenue function is 285x minus my cost is 225x plus 15,000. So I'm going to have 285x minus 225x minus 15,000. So I end up with what? 60 minus 15,000. Now, gang, what's that 60 stand for? It stands for the marginal cost, doesn't it? It's the cost to create an additional unit. I'm sorry. No, forget that. This is marginal, I was wrong, profit. Because, guys, we created the profit function. So that's the first mistake I ever made, right? Yeah, right. But marginal profit tells me the profit that I get from each additional unit. So my profit, every additional unit that I create, I'm going to increase my profit by $60. So really I've answered the problem right here, because the break even was at 250. I want to know what that extra unit contributed to profit. So the additional unit contributed $60 to profit. It wouldn't matter if I was at 400 units and I wanted to know what the 401st unit contributed to profit. That's always going to be the marginal profit. That'll be the slope of the profit function. All right. Now, the next problem was motivated by some friends of mine who actually contacted me the other day, and let me give you the question they asked me. They actually do things kind of like this. They actually go to fairs and they actually create. She's very, very creative, and so is he. But they called me up and they're like, we're selling this product for $30, including tax. But when we keep our books and stuff and pay taxes to the state of Kentucky, we need to know how much money we actually got in tax and how much we actually sold the unit for. So what's going on here is this product was sold for $118.72 that included tax. What was the original price of the product before tax was added, right? Well, everybody knows that all you'd have to do is take 118.72 times 0.06 and get $7.12, which turns out to be the tax. Then everybody knows that we would take 118.72 and subtract 712, which is the tax, and get back to the original amount. So we know that the product was sold for $111.60. Now, for those of us that really care about math, we can check this, right? We can say, well, if the original product was sold for $111.60, so this is the product, and then we can calculate the tax at being $111.60 times 0.06. So the tax was $6.70. So we add the $111.60 plus the tax, and go, oh crap, we're wrong. Why are we off nearly 42 cents? Well, guys, the reason we're off by 42 cents is all this up here is complete and utter garbage. This is not the way that we work this problem. Everybody tries to work it that way. They want to take the number that they're given, these two numbers that they're given, multiply them together, do something goofy, and come up with something goofy. Guys, that's not the way we work this problem. And this is what they were trying to do, and it just didn't work. So I set you up for failure there, guys. I won't do that very often. Hopefully you didn't shut off the video, and if you did, that's your fault, not mine. All right, so what are we going to do here? Well, what we're going to do is we're going to think about this systematically. What are we looking for? So what are we calculating here? Sale price. It's unknown, so I'm going to let it be X. Tax rate is 6%. And as you're going to hear me say many, many, many times over this class, don't ever use a percentage in mathematics or arithmetic. If you do, you'll get something stupid. Always convert to a decimal, so 0.06. So let's think what happens, all right? We've got this original price of X, and then we're going to add tax to it. And then we're going to end up with the amount that the product was sold. Now, guys, remember in algebra, if there's not a number there, it's a 1. So since we've got common terms, I can add. So I get 118.72. Clearly, I'm going to want to divide both sides by 1.06. So when I take 118.72, I get $112. Well, that's cool. I didn't know it turned out perfectly. Guys, the correct answer would be $112 and not $111.60. The other would probably get you in trouble with the federal or with the state government. This one, if you do arithmetic algebra correctly, you'll stay out of jail. Okay, well, okay, maybe that's a stretch. Gang, let me tell you what's coming up the rest of this week. You'll have 2 more videos. An upcoming video will be on supply demand. We will look at supply demand functions that are linear, which is the simplest case, and come up with equilibrium points and find out places where what happens when the supply is greater than the demand and vice versa. And the next thing we'll get into are exponential functions. I say quite a bit in this class that this class, at least early on, has a lot to do with how we get from point A to point B. Because in a finance class like this, in a math of finance, finite mathematics as we call it, what we often have here is we often have our dependent variable as money, and we have our independent variable as quantity, number of items produced. And the way that, and this could also be over time as well, depending on the nature of the problem, we may have a certain amount of money we invest at a starting time, and we have our money that's raised to a particular value over time, or we may have a cost for a particular quantity, and we want to see what the cost function looks like, at a quantity that's higher. Well, one way that we look from point A to point B is a linear function, and that's what we studied so far. But there are other ways to get from point A to point B called an exponential function. These functions right here, the linear functions, have a lot to do when we're looking at cost and revenue functions in this class, in the simplest case. But sometimes when we're looking at values over time, we get in situations where we get exponential functions, and that's there's a certain type of compounding investment schedule that we study that we'll actually use that. So, gang, I'm done. Hopefully these videos aren't too crazy. I know one thing, today it's raining and nasty, and I'm sitting here thinking how thankful I am that I don't have to get in the car and drive to campus and give this very same lecture to you sitting in a classroom, when I can do it sitting here in my house where it's really dry and kind of cozy and quiet. So, gang, have a good one.